Welcome. My name is Constantine. I'm with MTI Instruments. I'm an engineer with the General Instruments line of product development. This video will be an introduction to the principles of capacitance, the means of measurement, different ways that we actually measure things, principles of capacitance. Capacitance itself is actually a fundamental principle of electricity. You can kind of think of it like magnetism. So with magnetism, you have a north pole and a south pole, and there's an attraction between the two, and they're always attracting, or there's a repulsion between two north poles. In electricity, capacitance is actually the attraction between an electron and a hole, and those two units kind of form a pair. So wherever you have electrons, you'll have them be attracted towards holes in a conductive material. When you have two conductive materials, say two plates, or a plate and a wire, or two wires, you actually have capacitance between them, provided there's a difference in potential. And when you have that difference in potential, you have one side have more electrons and one side have more holes. So what will happen is the electrons will actually accumulate as they're trying to match up with the holes in the other conductor. They could be constructed in a lot of different things. When you have these two plates or two materials, there's a dielectric in between it. And dielectric is another term for the substance or the material that has the electric field lines, which are essentially the equivalent to the magnetic field lines. Those electric field lines are how we perceive and comprehend the capacitance or an electric field that builds up that charge between them. So with different dielectrics, you have different properties of capacitance. You can have air, you can have ceramic, you can have electrolytics. Those are all different types of dielectrics that you would see used in the construction of capacitors specifically. In our case here at MTI, what we're looking to do is to actually measure the capacitance between, in our case, the probe face and a grounded conductive target. In our case, the dielectric would be air. So we would actually be taking into account the fact that we have air, and air is really good because in a lot of different conditions, you have a pretty consistent dielectric value. So for a given gap, you would know that the capacitance is a certain value for your probe face. There's many different ways that you can measure capacitance. We have a couple of models here that we use to determine what the capacitance is of a probe face or of a probe in order to measure the distance between a probe face and a target. One of them is an oscillating model. So essentially, a very common way of perceiving electricity is a water flow model. So with electricity, you have water flowing down through pipes. And in this case, capacitance gets represented as a water bucket. In this case, when you have a probe face going to a target and you're moving that probe face, you're changing the capacitance. So in that water flow model, you'd have this water bucket magically growing and shrinking in size. And in the oscillating way of measuring this capacitance, you would have a tank that constantly supplies water to this water bucket, and it constantly drains water from the water bucket. So you can actually see what the size of the tank is by how long it's taking to fill up and drain that tank. Another way of measuring capacitance would be a discharge timing method. In this case, you would have a pipe that has a very fixed size and that you know the size of, so you know the water flow rate coming through that pipe attached to the bottom of that tank. And you'd have the tank fill up completely. And once it's filled, you start a stopwatch and you start draining the water from that pipe, from that tank. And you time how long it takes for that tank to completely drain. Based on the time it takes for that tank to completely drain, you know what that size of the tank is. So when you have that probe moving further away or moving closer to your target, you can just say, hey, I know it took this long for it to completely drain, so I know that the capacitance must be this. If you know the capacitance, you know the distance between that probe and target. In conclusion, whether you're building out an assembly process or looking to incorporate our products in your design, we would be happy to work with you. Reach out to us at mtiinstruments.com to see our full product line and see how we can work with you. Thank you.